Okay, so if we need to graph this function, g of x equals 2 to the x minus 1 power. Um, yeah, so it sounds like graphing using Alex might be the toughest part here. So the first thing we'll want to do is just to get an idea of what the graph will look like. So what we can do that is we can get some values that are going to be on the graph. So if you plug in like x equals 1 into this function, and I'm choosing that because if you plug in x equals 1, choose x equals 1, then 1 minus 1 makes 0, then 2 to the 0 power makes 1. That's a nice clean dot, okay? What Alex wants you to do with each of those points is to use this pencil tool, go to 1, 1, and then put a dot to let Alex know your graph needs to go through that dot. Okay, so let's do another one here. If you plug in x equals 2, that's another nice one because 2 minus 1 makes 1, then 2 to the first power makes 2. So we're going to put another dot with Alex at 2, 2. And then maybe we can get another one just if you plug in x equals 3, then 3 minus 1 makes 2, so 2 to the second power makes 4. So 3, 4 is a dot here. Okay, and that's probably enough. So to make the graph in Alex, I got to use the horizontal line. And the reason why the horizontal line has to happen with an exponential function is because you never actually get to y equals 0, right? You can't plug in a number for x to ever make this y, g of x. There's no way to make this equal to 0. You could plug in x equals negative a billion, and negative a billion minus 1, then 2 to the negative billion minus 1. That's still not technically a 0. Okay, so that's why the horizontal asymptote happens there. And then after you click that horizontal line, you see that Alex is saying this thing that says placing first point. So you just click on where that first point was. Then you can click on where that second point was. And then it makes the graph for you. Okay? And so for this part, the domain represents all the x values that are possible. Okay, so negative infinity to positive infinity because the line keeps going infinitely to the left on the x-axis, and then you can plug in a number. It goes infinitely to the right on the x-axis, okay, if you keep drawing that graph. Or you can look at that algebraically. You can plug in any value for x, and you don't have a divided by 0 problem. You don't have a square root of a negative problem. Okay, and then the range, that's best done graphically. The lowest value here is a 0. And the highest value, well, actually, we never reach a highest value. It's infinity, right? 0 is as low as we go on the y-axis. And infinity, there's no limit to how high we go on the y-axis. Okay, so let me see if I can submit this. You can just hit enter. I'm zoomed in here. Oh, it's down off the screen. If I hit check, it's got to mark correct. Okay. Let's see if I can find a different one. Okay, so with this type of graph, I'll go a little quicker this time. So a point I want to plug in x equals 0. 3 to the 0 is 1. 1 plus 3 makes 4. If you plug in x to the first power, then 3 to the 1 is 1. 3 to the first power is 3. 3 plus 3 makes 6. And that's all you really need for Alex is 2 dots. And this one's a little bit different, though, for the horizontal axis, okay? For the horizontal asymptote. Because when you're trying to consider the lowest and the highest possible values, let me see, actually. Zero, 4, 1, 6. That's all looking good. Okay, so the lowest possible value for this graph is going to be, on the y-axis, is going to be 3. And the reason is because if you plug in x equals negative infinity, you can make 3 to the negative infinity power get really close to 0. So this term here is the only thing that can fluctuate because that's the only thing that has a variable on it. And the lowest value you can get out of an exponential function is 0. So 0 plus 3 makes 3. So the lowest this thing can go is at 3. That's why the horizontal axis has to be here. Okay, and I'll show you another way of figuring that out other than by eyeballing. Okay, but let's finish graphing. Placing the first point, Let's do 0, 4, the first point that we figured out. And then let's do 1, 6, that's the second point. There's the graph. Let's do domain again. That's negative infinity. Oops, I got it right there. Negative infinity to positive infinity. And then the range is 3. And I'm using the parentheses because we never reached 3. That's the lowest it can go. And infinity is as high as it can go. Okay, so if you're wondering how I knew the horizontal axis should be there, here, I'm going to move this so you can see. Go to desmos.com. Desmos.com/calculator, okay? And then you can type in the right side of the function, 3 to the x plus 3. And that gives you a rough idea of what the graph looks like. Here it is at 1, 2, here it is at 3 on the y-axis. There's a horizontal asymptote. So in case you didn't know how I found out 3 was the horizontal asymptote in that last problem, that's a different way of how you can do it. Okay, let me see if there's any different ones. Yeah, this one's different. So let me do this one real fast as an example. Again, start with getting a few points. Let's do plug in 0 for x. Then 1/4 the 0 power is 1, but that negative sign applies after. Negative 1 plus 1 makes 0. If you plug in, let's say negative 1. Okay, and the reason why I picked negative 1 is because 1/4 is 0.25, right? If you do 0.25 to the negative first power, it gives you a nice even 4. So it's a nice number to work with. So if you plug in negative 1 here, this term becomes 4. So negative 4 plus 1 makes negative 3. So we got our 2 dots. And then again, you want to check for asymptotes. And so you could use Desmos to graph the function first. So the function that we had was negative 1/4 the x, and I think it said, oh, I forgot, did it say plus 1? Yeah. There's the graph, and you can see there's a horizontal asymptote, never quite reaches x equals 1. So when we do this graph, here it is at x equals 1. Y equals 1. I said that incorrectly. It never reaches y equals 1, right? So the horizontal asymptote happens at y equals 1. There's a horizontal asymptote. First dot is at 0, 0 that we got over here. Second dot's at negative 1, negative 3. Put a dot there. There's our graph. And again, the domain is negative infinity to positive infinity because all numbers are okay to plug into an exponential function. The range, though, the lowest value we can get is negative infinity. And the highest value we can get is 1. All right, let me hit the check button just to make sure I didn't mess anything up. That one checked out. Okay, so let me check one last time to see if there's anything else. Same type of thing for this one. Okay, so hopefully that helps. If not, please let me know what I can do for you. I'm happy to try something else. Okay?